Now let's nerd out with writing some simple simulations inside of Python.
Sounds great.
For this first puzzle, using Python, collect 13,000 observations of rolling a single 6-sided die. So we're going to use the 6 steps that we summarized to write this simulation. So the first step is we need to create a data variable that's going to store all of our data as a list. So data is equal to square brackets. And then we are going to simulate 13,000 dice rolls. So for I in range 13,000, no commas, so 13000. And then the third step is to simulate all the real world variables. Here, there's only one real world variable. It's the it's the one die that we're going to roll 13,000 times. So I'm going to say die is equal to random.rand int 1,6 to randomly roll that die. And then I'm going to store that die inside a dictionary. D is equal to curly braces in quotes die for my die roll is equal to die, or sorry, colon die. We're assigning dictionary entry die to die. And then finally, we're going to say data.append of D to append that dictionary to my data list. And then finally, outside the for loop, so we have 3 lines of code inside the for loop. These are all indented. And then outside the for loop, we are going to simply say df is equal to pd.dataframe with D and F of data frame capitalized of our data. And then what we have here is we have a series of 6 lines of code that is going to do our simulation. I would run this as it is without even printing out df and see what we get.
So I need to definitely import random, and I also need to import pandas as PD.
Exactly, and if you didn't, you'll just get an error that says it doesn't understand that, and that's going to be a common error that I see all the time because I always forget to import them. And it's a really quick fix though.
Yes, just fixed it, and now nothing happened.
Awesome, and now in the very next cell, let's go ahead and print out df.
And I see 13,000 rows and 1 column labeled die.
Awesome. And now the analysis question. What is our estimated probability of rolling a number less than 4? So Carly, let's think about this statistically first. So a number less than 4, so that's going to be a 1, a 2, or a 3.
Yep.
And how many of the 13,000 rolls should be that?
Half.
Half. So 13,000 divided by 2 is what, 6,500?
Yep.
Is our actual expected value. And I want to know how many times it's appeared in our data set.
Right.
So here we're going to have to write a conditional to select a subset of rows. So the rows we want to select are going to be all the rows with the die value being less than 4, right?
Yep.
So here I can simply say df at df.die is less than 4. And by doing df.die is less than 4, that should select only the rows where the die value is less than 4. And how many rows did we get?
6,541.
6,541. So we see that our estimated probability is right about at 50%. That we got in our simulation almost exactly what we expect to see in the average case. And this time we got a little bit lucky. We had 41 high rolls that we didn't expect to get, but it's very, very close to expected value, and simulation is always going to be an estimate. So, a second question. Using Python, collect 10,000 observations of flipping 2 fair coins.
Ooh.
So we have 2 fair coins happening now. So I'm going to go ahead and use the same pattern. So data is equal to an empty list. For I in range, here we're doing 10,000 simulations. And then now we have 2 real world events. We have 2 coins that we have to flip. So I'm going to call this coin 1 is equal to random. And Carly, here's an interesting choice. Do we want to use 0 and 1 for heads and tails, or would you rather use words?
Ooh, that's a good question. So
Completely up to you.
I think I'd rather use 0 and 1, to be honest.
I often like numbers. They're kind of easier to work with in my mind.
And if we want to do any statistics on them afterwards, that would be a lot easier.
And it's less typing, so I love being lazy.
Oh, yes, you do.
Random.randint 0, 1 to have a number either 0 or 1. And I'm going to do the same thing for coin 2, where I'm going to do random.randint 0, 1. And then I need to accumulate these values inside a dictionary. So the fourth step, D is equal to curly brace, coin 1 in quotes, colon, coin 1, comma, coin 2 in quotes, colon, coin 2 in my curly brace. And then I need to add this dictionary to my list. So data.append D. And then finally, df is equal to pd.dataframe of data is going to create a data frame out of this. And notice, just like before, the 4 lines that I want to run 10,000 lines are indented, but that df is equal to pd.dataframe. We only want to create a data frame out of everything at the very end. So that line, that last line, is not indented. So if I run this block of code, again, nothing should happen. That's going to indicate that the computer ran the code without getting any errors. So what do we see, Carly?
So when I run df, I see a data frame with 10,000 rows and 2 columns, labeled coin 1 and coin 2, and each column has either a 0 or 1, and it looks pretty random.
Awesome. So now our analysis question is, what is the estimation of the probability of flipping 2 heads? So before we do the estimation through simulation, I'm interested in, Carly, can we give us a predicted result just to make sure our simulation is correct? So what is, just using statistics without looking at data first, what do we expect the value to be of the probability of flipping 2 heads?
Of flipping exactly 2 heads, so yes. A head and a head. So that should be 25%.
So we expect to be 25% of all of our coin flips, and we have 10,000 coin flips. So 25% times 10,000 is 2,500. So our expected value is we have 2,500 double heads. I want to see, is this actually going to happen? So here we have, if we look at our data frame, we've got coin 1 and coin 2, right?
Yes.
And do you want heads to be 0 or heads to be 1?
Let's do, usually heads is 1.
Okay, so 1 is our heads. So when they're both heads, what's the data frame rows that are both heads?
1, 1.
Okay, so we need a conditional that says only when coin 1 is equal to 1 and coin 2 is equal to 1.
Yes.
So we'd write this as df at, and then because it's a multi-part conditional, we need to put a set of parentheses around it because we're going to be anding them together. So df, open parentheses, df dot coin 1 is equal to 1, and a single ampersand to join these together. df dot coin 2 is equal to 1 is the second conditional, close out the square brackets. So now we're doing a subset of rows, and we want only the subset of rows where df.coin1 is 1 and df.coin2 is also equal to 1. And if we do that, and if we get the syntax completely right, then we've got 2 conditionals inside of different sets of parentheses.
Oh, okay. I need to make sure to close the parentheses between the ampersand.
Yes.
That was my error. I just tried to run it and it didn't work, but this should do the trick. And I see 2,470 rows and 2 columns that are always equal to 1, 1.
Yeah, so out of the 10,000 dice rolls, 2,470 had double heads, which is, again, very, very close to our estimated value.
Very close, yeah. Wait, actually, as we were doing this, I was thinking another way you could do this problem, could you also just create a new column and add the 2 coin flips together and say when that column is equal to 2?
Oh, interesting. I didn't even think about that, but because we have numbers, that's great.
Yeah, that was how I would have thought to do this, but both of them give you the exact same result.
So that's 2 lines of code, so let's just do that real fast.
Okay, might as well.
To add a new column, we'd simply say df at sum is equal to df at coin 1 plus df at coin 2. And I use the at notation here. You can also do dot sum, dot coin 1, dot coin 2, whatever your preference of syntax is. And this adds a 3rd column to the data set called sum. So if you just type out df afterwards, you should see now your data set has coin 1, coin 2, and sum.
Yes, exactly.
And then our conditional becomes a lot easier now.
Right.
So now we don't need a complex conditional. So now it's simply df at df.sum, or df square bracket quote sum, is equal to 2. You may not be able to use dot sum here because dot sum is actually something else.
Is actually, yes, function, right?
Yeah.
Yeah. And I got 2,470 rows.
2,470. So we see we got the exact same result, which is exactly what we expect. So that's a clever way of doing it because you did a little bit of extra work to make your conditional a little easier.
Exactly. And with any of these problems that we're doing in data science, it's important to kind of think about them and think, are you writing your code to optimize how much work you have to do, basically?
Yeah.